So again, welcome everyone to our Turing-Roche Tech-Talk series, which aims to share technical resources and knowledge to improve how we do computational-based work, specifically in the medical sciences. If you weren't aware, the Turing-Roche partnership has been established to bring together researchers across academia and industry. Through this, they have several community scholars with different projects, of which I am one. And as part of my project, I'm running this seminar series. So with that, I will introduce our speaker, who is Carlos. Carlos is a research software engineer at the Alan Turing Institute. He has developed software tools for synthetic data generation, but with an emphasis on protecting the privacy of the users in sensitive data sources. And before this, he obtained his PhD in software engineering from UCL. So without further ado, here is Carlos talking about how VS Code can improve your workflow.
Oh, thank you, Helen. May I share my screen?
Yes, please.
Give me 1 second. Okay, can you guys see my slides? Okay, great. Well, hello everyone. My name is Carlos Gavidia-Calderon, and right now I'm a research engineer at the Reg team, research engineering group at the Turing. I've been working for Reg for a bit more than a year right now. We do VS Code in Reg, and we do Python there. So I'm going to tell you some of the tips and tricks that I use when developing Python programs using Visual Studio Code. Okay, I started coding in Python at the beginning of my PhD. That was almost 10 years ago. And I was always of an IDE guy. So I used to use UIs for developing software. And the first one that I used was one called Spider that came by default with Anaconda. I tried Atom as well. Sadly, Atom has been canceled. And I used PyCharm for a long time during my PhD and also during a few postdocs. But when I joined Reg, I found out VS Code is really popular. We have a set of guidelines on how to use VS Code within the team. And I really, really like it. And today I will share some of the things that I do like about VS Code and Python development. But something that I want to make clear is tools for development are something I believe it's really, really personal. I have some colleagues at Reg that they are wonderful with PyCharm and they can be very, very productive with PyCharm. Some other colleagues, I don't know, they don't like color. They do everything on the terminal. And they love Bing and they love Nano, and they're really productive with that. So I don't try to tell you that VS Code is the best, but I will tell you what do I found useful about this tool, and hopefully you will find some of these tips and tricks useful for your workflow. Now, let me tell you what I want to talk about today. So VS Code is an IDE that's extensible. So you can add features to the IDE by installing extensions. So I want to tell you what you can do with the Python extension. There's also an extension for source control for connecting to Git repositories. I want to touch on that as well, because yeah, even with Git, I like to do it with the UI. A couple of tricks on code navigation. If you're dealing with a large code base, how can you explore it more efficiently? And a tiny bit at the end about using Jupyter notebooks within Visual Studio Code. Now, I'm not reinventing the wheel. Most of the content that I will be presenting today comes from the official tutorials from Microsoft and Visual Studio Code. And also, I need to say this is a very beginner-friendly talk, so I will start from the very fundamentals. So maybe if you already have some experience with that tool and you want to go at your own pace, feel free to check the tutorials and do them all. The content, it will be really, really similar. Okay. Another disclaimer, I will show you basically what I use in my daily work. Again, you might have some different preference, but this is the software stack that I use. So today you will be seeing me using a Python interpreter, and I'm using right now Miniconda. There are many other options, but this is the one that I'm using today. You will need Git installed in your system. Probably you're already doing that. And at least in the Turing, we use GitHub as our cloud repository for Git. So I'm going to be, for a part of the talk, really GitHub focused. So people like GitLab, there are Bitbucket as well, they have a GitHub repo, but you use what you need to use. Today, I will be focusing on GitHub. This is a Visual Studio Code, so we'll need to have Visual Studio Code installed. As I mentioned, I'll be covering the Python extension. You might need to install it. And yeah, as a proof of concept demonstration, I will be exploring a data set of Titanic passengers. So, and if you want to also explore the data set, there's a link here. Now, given the introduction, let's go into the code. So, when you're working with Visual Studio Code, normally for each one of your projects, you will be creating a workspace. What's a workspace? It's a folder within your file system that will hold all your files related to your program. So let's start by doing that. Let's create a workspace. And for that, let's see if this works. Can you see the terminal? Great. So well. So where am I right now? I'm on my home directory, and I'm going to create a folder that will be my workspace for today. Okay, there, VS Code, Python tutorial. Okay, that worked. I'm going to go into this folder that I just created. VS Code. Okay, I'm there. Just checking if I'm there. And I'm going to run the command code. Normally, when you install VS Code, this gets added to your path variable. And I will tell VS Code that for my workspace, I want to use my current directory. So I will put that up there. Now I'll wait for a bit. And voila, there's VS Code in my workspace. That's the folder that I just created. Now, something very, very useful, like it's my preferred way of interacting with VS Code, is using the command palette. So the command palette is, you will say it right now, in macOS, you press Command-Shift-P, and you can see, you just type the name of your command, and it will execute it for you. And what I want to do it right now, there's a feature called like toggle screencast mode. Do you see that? I just press TO, and VS Code tell me that there's a command for that. And because I have screencast mode, I can like increase the zoom. So you saw like the keys I'm pressing where I'm doing click is a bit highlighted. So hopefully this will help with this presentation today. Okay. So that we did it. We have a workspace within VS Code. Now, what else? Okay, now, again, like this talk is not about Python best practices, but there's a best practice that I believe that every Python developer should embrace, and that's like working in environments. And it's actually a recommendation from the Visual Studio Code website. Like if you have a workspace where you're going to work with Python, it's recommended to create a virtual environment. What's a virtual environment? Like it's an isolated environment, or you can call it context, that's composed by a Python interpreter and the library that you want to install. That way, like, I don't know, like if you're working with some old software that depends on Python 2.7, you can have this project set apart from your other projects that depend on a different Python version or with some other modern libraries. It's always a good thing. Like if you create a workspace for Python, you also create a virtual environment. So you do not pollute, especially do not pollute your Python installation in your operating system. And we're going to do that. Let's go back to VS Code. I'm going to use my command palette, and I'm going to look for virtual create environment, Python create environment. I'm going to click here, and VS Code is asking me what type of environment do I want to create. I have to say there are like two more popular ways of handling this environment creation. The one is using a virtual environment, is the virtual environment functionality that comes with Python out of the box. But as I mentioned, I do like Conda, so I'm going to create a Conda environment. Click here. Now, I also need to select which version of Python do I want to use. I'm just going to go with the latest one, Python 3.11. And now VS Code is handling the environment creation for me. This can take a while. You can see I have created this like .conda folder within my workspace, and it's initializing it. It can take a while. That's it. So once you have created your virtual environment, the next step is you need to activate it or tell Visual Studio Code, whenever I'm trying to run Python in this workspace, I want to use this virtual environment that I just created. If you're seeing here that that's already done for me, like, but sometimes it doesn't happen. So if you want to do it, again, like you go to your command palette, there's a command called select interpreter. And you are just like making sure that the interpreter, Python interpreter that VS Code will use is the one I just created here. You can see here that I have a lot of virtual environments because yeah, like every time I embark in a new Python project, I do create a virtual environment. But today we're using this one here. Okay, now how do I know that that worked? Something that I like to do, if you click on terminal and you click on new terminal, that's another feature that I really do like a lot about like VS Code. Like I don't need to go to the terminal program from macOS. I manage my terminal and my tabs all within VS Code. And you can see here that my prompt is preceded by .conda. It's telling me that the Python version I'm using is the one contained in my virtual environment. If I want to be even more sure, something I like to do is tell me which Python you are using right now. And you can see here that whenever I type Python, I will invoke the interpreter within my virtual environment. Okay, now go back to the slides. We have done this. We have created a virtual environment using Conda. I did 3.11, but I think it should be all right. I have told VS Code that I want to use the interpreter for my virtual environment. This bit, I did it already. So now let's write some Python code right now.
This is something. Sorry to
yes.
interrupt. I think someone had their hand up. I think it was the real Levin.
Yeah, is it okay to ask a question, or should we save it for last?
No, please go ahead.
Just what? So there's .conda and then base. Can you explain what that means? Is there like
.conda and .venv?
No, there's .conda and then base in parentheses, like showing.
Oh yeah. So this is some Anaconda thing. So like when you install Anaconda in your system, it comes with a base environment, and that's the one here. But on top of base, I'm created another environment, which is my .conda one, which is the one like referred here. I don't know more of the specifics, but for practical purposes, I'm using the virtual environment that I just created right now, if that makes sense.
Yeah, I was always wondering, does it have any consequences that you have the base and then on top of that something else? So whenever I open VS Code, I do conda deactivate just to go at like deactivate everything and then activate the environment that I want, but maybe that's not necessary.
Yeah, that I'm not sure. I noticed that this happens when I do environment creation from VS Code. So like if I create the environments outside VS Code, yes, like I don't know, like from my terminal, conda create environment, I don't see this thing. But yeah, like right now I cannot give you an answer. Maybe later I can check and I will reach out with an answer.
I'm pretty sure that the base environment, I mean that the conda environment is just what's being used, and visually it looks like, because it's basically just initialized the base before you've initialized the conda, that's why you see both. But I think functionally it's the same. And there's also there's something that you can put in your like conda ARC file if you don't want base to always be initialized by default as well.
That makes sense to me.
Perfect, thank you.
Okay, slides again. Okay, let's do a bit of Python. And this is something I'll try to avoid all my life coding, but I'm being brave today. So I'm going to code in front of an audience. I'm going to create a Python file. Like notice, again, like in VS Code, there are many ways of doing the same thing. For creating files, what I like to do is right-click, new file, and I'm going to create a file called Titanic.py. Voila, it's created there. Now, like maybe I can show you this right now. Like if you're looking here, what I'm trying to do is I'm just like loading this CSV file using pandas. So if I do import pandas as PD, and maybe this is something that I can show you right now. If I want to run a Python script, remember, VS Code already knows what interpreter we want to use. I will click this button here. I just want to run this line. And well, I cannot see it right now, but you can see here. What happened? I don't have pandas because I just created a brand new virtual environment. It only has Python. It doesn't have pandas. So if we want to install pandas within our virtual environment, let's use a good old friend pip. Python-m pip install pandas. Yeah, we'll need to wait a bit. And given that I have my local environment activated, it will add the library to my virtual environment and not to, for example, the base environment that I have on my operating system. So like, given that it will take a while, oh, it didn't. This is fast. Okay. Now, if I run my Python script again, I shouldn't see an error right now. It's a bit slow. I think I need a new laptop from the Turing. Anyway, so far so good. So it's importing pandas. Let's keep moving. So I'm going to load a CSV file. I apologize in advance. I do like type annotations a lot, so I will annotate everything. And my CSV file is in my home directory in a data folder, and I think it's called Titanic3.csv. Oh. Some of the advantage of VS Code knows that I have this file here. Another thing that I do like, syntax highlighting. Sometimes I have worked with some Jupyter notebooks on the web that they don't color the code like this. I do like a bit of color, as I said. My file name. Okay, now I can load my data frame. Again, tap annotation because they're great. I will type pd dot. Why it's not doing autocomplete? Found this, okay. There it is, it took a while. I do need a new laptop. So look, pd dot, and VS Code already knows which functions are available within the pandas module. So it's suggesting me like maybe you want read CSV or read Excel. Again, good thing to know. And some other things like I have access here to the function signature. In some other libraries, you can even see the doc string. In this case, I'm not having it. But again, something useful when you're coding, that you have access to the documentation. Okay. I know that I have my data frame loaded. If I didn't make any mistakes, I want to check the first few rows. Look at that. VS Code has been really helpful, telling me what I should code. Again, that's something convenient that normally you don't get it when you work on a Jupyter notebook on a browser. I'm going to run this file again, and let's see if I didn't make any silly mistakes. Okay. So far, so good. So yeah, this is one of the things that, well, easy win that we get out of the box when we work with the Python extension. Syntax highlighting, autocomplete, and some convenience for running my Python script. Okay, we did that. We have checked autocomplete. We have run the programs, and I have installed a library via terminal using pip. No rocket science there. I created a terminal, I think I did. And I did that. Okay, so far so good. That's how you code in Python with the Python extension. Okay, now, this bit I think I'm going to copy paste because like with Seaborn and Matplotlib, up to this day, I need to go online and see how to do it. And let me, yeah, I'm not as brave enough as to code like some Matplotlib code by heart. Let me copy this. And go back to VS Code. Okay. Well, we can read our CSV file, so far so good. What if we want to plot some variables? So within our data set of Titanic survivors, so we have how many people survived, and we have the sex of the survivors, and we also know their age and how much did they pay for their ticket, the fare. So let's plot them using violin plots, and let's see how it goes. So look, the page is going weird. I've been trying the whole weekend to get it to work, but it didn't. So I'll just like edit, and hopefully it will work right now. Okay. That's looking good to me. What's pending is I'm using the Seaborn library, so I will need to install it. I'll just do it right now. Again, I'm in my virtual environment, so I can just go ahead and install Seaborn. Now I tend to use Seaborn a lot. Yeah, the plots are just prettier than if you're doing plain Matplotlib. That work. So now, like, given that I'm using SNS for the Seaborn library, I'm going to import it. Import Seaborn as SNS. And if I want to see my plots, I will need to use pyplot and call the show method. But I haven't imported pyplot, so I'm going to do it right now. Or matplotlib, again, like, look how smart is VS Code. It knows I have matplotlib in my virtual environment. And, well, let's see how I did. Invalid thickness in line 3. Is this a false positive? No, yeah. It's all right, I think. Now let's see. I'm going to run this code. I'll click my play button. Now I have a bug. And this is on purpose. It's not that I made a mistake. Because I want to show you like how you can debug your scripts using VS Code. So yeah, like when you're coding, like in Python or any other language, like making mistakes, it's part of what you do. And mistakes are also bugs, the way we call it in software engineering. And the process of identifying bugs and removing them is what's called debugging. I'm sure you all have your own like ways of how to dealing with bugs. Something that I used to do a lot is I just put print statements all over the place until I found a problematic line for me. That works most of the time, but sometimes you need something a bit more powerful. And like when you install the Python extension, maybe it's a good time to show you these Python here extensions. You can check which extension you have installed. You will note that along with the Python extension, you also get the Python debugger extension for free. So VS Code comes with a debugger called debugpy, and we can use it for identifying bugs and removing them. And I'm going to show you how today. Okay, so how do we use a debugger? And by the way, like I'm going to show you this debugpy debugger, but like debuggers in many programming languages, I know at least in Java, they work basically the same. The first thing is you need to like define a breakpoint. So at what point of your program you want to interrupt execution, so you will take a look at the program state in variable values, for example. So let's be a bit like overcautious, and let's put a breakpoint in line 5. my very first line of my program. If I put my pointer here, VS Code tells me click to add a breakpoint. I'm going to, I see the red dot here. I have defined a breakpoint. Now I'm ready to invoke a debugger. Again, VS Code, many ways of doing the same thing. I'm choosing to today press S5, and that should trigger the debugger invocation. Well, I have the Python debugger that comes with the debugging extension. That's the one that I want to use today. Click. And now I need to provide more information. Like, debugging can be intricate. So like, it's one thing to debug a script in my laptop. It's something completely different if I want to debug a Django web application, or if I want to debug a Python program that's running in a remote server. DebugPy will need different kind of information. Like, we have some templates that are provided by VS Code. Sometimes they are enough for your use case, but I dare to say like many times you will need to tweak with them. There's a configuration file called launch.json where you can definitely tailor how you're going to invoke the debugger. I'm not going to cover that because that launch.json is a whole world, but normally, like if you go into Google and ask, for example, like how to configure launch.json for, I don't know, like running unit tests with PyTest, you will find some good support there. Or maybe ChatGPT, I don't know, I'm not a user, but I've been hearing that's amazing. In our use case, I just want to debug a simple Python file, and I know for sure that the default configuration will do the trick for me. We need to wait a bit. It's starting the debugger. Thing that we know is my blue bar here, it's turned orange. That's an indication that I'm using the debugger. You can see my line 5, it's all yellow right now. And that means that execution has stopped. A really useful feature of the debugger, if you can see here in this pane in the top left, I can see my local variables and their values. So far, I only have local variables for the modules that I import. Because remember, execution stopped at line 5. Now, what you're seeing here, if the zoom controls allow it, are for controlling how do I want to traverse my program execution. The most useful button for me is this guy over here. I think it's a step over, which is just given a line, run it. I want to see what this line does. So I want to run line 5. I will click step over. And if you can see here, the effect of running line 5 is just I created a variable file name with the value t2nextdata.csv. So that way, line by line, you can see how program state evolves. And you can hopefully detect with this additional information in which part of your code you made a mistake, or the developers of the library made a mistake. Some other useful thing to do is if you see this button here, this is a step into. Sometimes you want to go to the execution of a function you're calling. From here, maybe something is going on within read CSV. If you want to go inside, you just click step into. Again, like sometimes you will need to tweak the launch.json to be able to access this, but today we're not doing that. Step over. So far, so good. My problem is not in these 2 lines. I will run this line 8. I'm seeing the output. So far, so good. And another feature that I want to use from the debugger that's really useful for me is the debug console here. So the debug console allows you to interact with your objects that are in memory right now. So look at this here. So right now I have in memory file name and data frame. So I want to ask them questions. Hopefully I will detect which one is the problem of my plot that I want to show it here. So for example, like I want to check, again, look at VS Code, so smart, it's telling me there's a data frame object. I want to check which are the columns of my data frame. And I can see the output right here. Again, this is really useful. You stop program execution and then you can see how your objects are behaving. And then we can see like there's actually a column called H, but we are invoking it with the uppercase H. Maybe that's the problem. Let's see how our data frame reacts when we are asking for the H column with uppercase. Yeah, that's not working. In contrast, if we invoke it with lowercase, then I'm having the result that I expected. So now I can say like, oh yeah, silly me, I made a mistake. I will click this button over here for, this is just continue. It will ignore my breakpoint and it will just like finish the program. Yeah, exception happened. And now, oh no, I'm sorry, my apologies. Yeah, it stopped because it detected the mistake. I'm going to just like stop the debugger by clicking this. I don't need the debugger anymore. I'll just go and correct my mistake. It was H, it was fair. And let me take one more look in case I did another silly mistake. Hopefully not. And if I click play, ta-da, I'm seeing my plot, survival for H unfair divided by 6. So this is how you use that debugging tool. Again, like really powerful. The only caveat is that you might need to tailor the debugger by tweaking with launch.json. But like it's totally worth it when you're dealing with some like cheeky bugs. Okay. Let me go back to my slides.
I might also just add something that was like also interesting when you showed that in the live demo, is that where the error pops up is on your line where your error is, like the debugger will give you where the exception is, but it won't exit out of the debugger. So you can still interact with the console at that point as well. And you can also inspect your variables at that point as well. So if you have a bug in your code, it means that you can run it in the debugger, it'll pause where the error is, and you can inspect what it is about your code that might be making that error. Often you want to go back and like put breakpoints in various places anyway. You might want to go back a few steps, but that can also be a good starting step as well, is just letting it run to where the error exists. I saw Levin, did you have a question as well?
Yes. So these are just probably just placeholder questions that if we have time would be good to come back, but things that I always found difficult and confusing with VS Code and debugging. Two things. So one was whenever I had to debug a function that calls another function in a different Python file. And oftentimes the debugger, if I put the debugger in a different function that is being called by a parent function, it doesn't stop. And I execute from the parent function, it doesn't stop. Sometimes it does, and I forget when it does and when it doesn't, and drives me mad quite often. The other aspect was coming from MATLAB being the first language that I learned, and then in Python, well, then R, and then in Python, I started with Spider, like you, Carlos. I love having variables available for me whenever I want, and to open them in like a variable viewer and look at that. And I think VS Code, unless you go into debugging mode, it doesn't let you do that. You can't just execute like individual lines and have variables there to look at them. And I'm just wondering why that's the case. Why is there some specific good software engineering reason why VS Code doesn't allow that? I know it does allow it with Jupyter Notebook style interface. You can view the variables there. But even then, the variable viewer is really bad. The Spider one is very good. And so is MATLAB and so is R. Those are the two things would be great to talk if we have some answers and points to discuss. Thank you.
Yeah, I can comment on that a bit. Yeah, I can totally relate to that. Like, at least for the very first time I said the debugger, it doesn't behave the way I wanted to. And yeah, like I think the last project that I was really trying to get the debugger working took me probably 3-4 hours of research and trying to get it working the way I really wanted it. But I tend to believe that it's worth the the effort. So when you have the debugger set up, yeah, there's no bug that can resist your debugging powers. But yeah, it's tricky. Like I think that can be improved. This launch.json file have a lot of options. And on the second bit, yeah, you mentioned like if you want a variable explorer or inspector, and we're going to cover that today, you can use Jupyter notebooks and you can have the feature there. But like I think like if you're working with like even like a medium-sized program, like the number of variables to manage becomes like unmanageable. Imagine like a Django web application. Like so there are some variables that you're manipulating from your code, but on the background, Django probably have like hundreds of variables behind it. So it becomes a bit tricky.
But those
So,
are easily managed, right? Like there are categories like local versus global variables and stuff like that. Like most of them, you don't need to see. It's more about like as more of like a data scientist, you know, if I'm working on some data analysis, I just want to have a few variables in the memory and see exactly how they change dynamically when I execute one line after another, not necessarily having to be in the debugger mode, which feels a bit constraining. Just whenever I want to be able to execute a line. Yeah, so that's what preference of one research data scientist, and I was wondering if others, yeah, share that. And yeah,
I guess
yeah,
like, oh,
go
sorry,
ahead.
I was just gonna say like I think an issue with that is it just has a lot of overhead. So if you're storing all your data all the time, something like R does, or I mean, you mentioned a few other ones, that's going to have overhead. So I guess doing it in debug mode, I mean, I often am running my code in debug mode anyway, but you're kind of opting into that overhead, as opposed to it being there by default. So that might be one reason. I also thought I'd comment on your question about the debugger not always working. I would say that VS Code is under constant development, and so is the debugger. And I've noticed it has got a lot better. One place that I noticed that it's not always great, is in Jupyter notebooks. And it seems to be that sometimes it doesn't like when you like dynamically add breakpoints when you're running it in Jupyter notebooks, but I don't notice that when I'm running just like my Python files. So, but yeah, anyway.
Oh, thank you. Like I have 20 more minutes, maybe I should continue.
Yes, please do.
thanks.
We talk about it. We have the debugger extension that comes for free with the Python extension. And also, like I think Ellen commented to me before, and I wasn't aware of that. Like we have some really good like Python extension packs that you just install one of these packs and you have a lot of extensions that are really useful. Something to keep in mind. We have checked how to add breakpoints, check how to start the debugger, we have used the debugger, and we have removed the bug. Okay. Now let's move to the second topic, which is like using Git. So Git is, again, sadly, I don't have time to talk more about Git, but it's a tool for basically enable developer collaboration. Like if you have a software project where you want to work with more than one person, Git is your best friend. And I dare to say, like here using Git, I'm in the minority. Like most of the people I know when they interact with Git, they do it via the command line. But I'm one of those weirdos that I do like buttons. So I will show you how I myself interact with Git. Okay. Yeah, the first thing is like we need to initialize a repository. Like in VS Code, we work on workspaces. In the Git world, like the folder that contains your code is called a repository. And your Git repo, you have your source code, you have some other files, I don't know, you have some data, you have some images, and more importantly, you have the revision history of your file. So it will help you keep track of your changes. So now, like as a first step, let's see how do we convert our VS Code workspace into a Git repository. Now, go back to VS Code. One of the extensions we have is this extension here, which is like source control. If I activate it here, so ready, like you have a workspace, then not a Git repo. If we click this button over here, it will do it for us. And now we have rally detected that we have one file and that file has been like updated. If we want to really, really be sure that our workspace is now a Git repository, we can go and check which files do we have here. And you can see, like alongside our Gavidia-Calderon environment, I have a .git folder, and that it's a clear indicator that now our workspace is a Git repo. Now, what else? Okay, making commits. So what are commits? Commits is your way of telling Git, I'm going to change these files, and this is my changes. This is the person who did it, and this is when they did it. So now let's see how to do it with Visual Studio Code. Now, Git commits function like in two stages. I'm simplifying a lot. Like first, you need to tell Git which ones are the files that you want to modify, and then you promote them to the staging area. And then when you have like all your changes in this staging area, you can do the proper commit and submit your changes. I'm going to do that right now. So this is my Lonesome Titanic file. I'm going to promote it to the staging area by clicking this plus over here. And then we save it. My changes are ready to be committed. Now, it's always like a good practice, and yeah, sometimes I don't follow it myself, but every time you do a commit, you should include also a descriptive message of what the change is about. Now, because I'm in front of the audience, I'm going to do it properly. Is plotting age survivors by pair and age. And then you click commit. And then if you can check, also you can check your commits from the VS Code extension. We can see that we have a single commit right now. So now we have an extra changes to one of our files. Now, skip with the presentation. Okay, it's time to talk about branching. It's another really useful feature offered by Git. Like, for example, like what if like you have some idea in mind, you have a stable version of your code that you know it works, it does everything you need, and you have a risky idea, and you want to try it first, but you're not sure, like, and you don't want to pollute like your really nice, tidy working version. One way of isolating your changes from the stable version is by doing branches. And let's try branching today with the support of Visual Studio Code. And in my branch, for demonstration purposes, I'm going to do this tiny refactoring here. Like I have all my code in a single script. I'm going to be tidy, and I will have them all in a function. Now, let's do it with VS Code. Another like Git concept that we need to be familiar with is like whenever we initialize a repository, Git already assigns us to a branch, to a version. Now it's called main. It had some all various names back in the past, but now it's called the main. So this is the default branch. This is the branch we've been working so far. We want to create a new branch. I'm going to rely on my command palette, and I will click on create branch. I'll need to assign it a name. I will call my branch refactoring. And that was it. If you can see here in the bottom left, I'm not working on my main branch anymore. I'm working on the refactoring branch. So I have opened like a parallel stream of work. Whatever I have in main, stay in main. Not all my changes will be added to the refactoring branch. And now I'm going to do my refactor. Let me move this, I need to get more space. I will, oh, this is not what I want to, I don't want to modify the token changes. I want to modify my Titanic data file. So I'm going to put all this code here in a function that I will be calling main. Now, if I want to move all these lines and I want to indent them to the right, instead of doing them like one by one, you can just press tab. Voila, all of them are indented. Python developer, you know indentation is really important. And now, like if I'm running my script, I want my function name to be called. And that should work. Let's see if it's complaining. What's going on here? Oh yeah, really another time to do a comment. Like, there's an extension that I really like that's called Flake 8. Flake 8, that static analysis code of your Python. It basically tells you like if you're following good practice or if you have an error. And Flake 8 can be a bit picky. So now it's telling me like you need to add 2 lines after every function. But today I will going to ignore it. And I'm just going to click here and I'm going to see if it's working as expected. Okay. Yeah, my refactoring works apparently. And now I'm going to commit my changes to the branch because I'm on the refactoring branch. Already checked how to do commits. Titanic. Look, if I click here, also this is another feature that I really like about like Visual Studio Code, and that's hard to at least visualize when you're using it from the command line. Look, like I have like a report on what I have changed. We can see that I have added a new line main and some lines, well, according to Git, I deleted them and I added the new ones. You can also have like some of this information if you go to your source code file. You see like this green bar over here? So Visual Studio Code is telling us, I consider this a new line, and these blue bars here are lines that according to Git are modified. So you can have take a look of the changes that you plan to commit. And like I'll use myself, whenever I take a look at this, I can see like, oh, I didn't meant to do this change, or maybe I should save this for later. I think we have 2 views. Now it's going on an inline view because I'm working on my little laptop. But if you have oh, it's not letting me limit. Yeah, because my space is limited. You can see the changes one next to the other, and that's way more convenient. But right now, VS Code is rebelling because I don't have a big monitor. Okay, I'm going to do commits the way we did them before. I will promote my changes to the staging area, and in the staging area, I will add a descriptive commit message because I'm a good developer. Refactoring by moving to main function. And I will commit this. And that's done. And look what happens. So like in my refactoring branch, I have my 2 commits. But on my main branch, if I can click here, I can quickly switch between branches. In my main branch, I still have my good old version of the code. That's something convenient. Like if you're working with some experimental code that might totally mess up the code that you have for your paper, open a branch, work it there, and then promote it when you have another paper coming. Okay, so that's creating branches. Now we have 7 minutes, so I'm not sure if I will have time to cover everything I wanted to cover. My apologies. I will skip merging right now. Publishing. But we're going to do a bit about like cloning. Well, merging is just when you want to bring content from one branch to the other. And publishing is when you have your code in your branch, how you move that from your local repo to GitHub. You can do that all from VS Code, but sadly we do not have the time. But I do want to cover cloning. So what's cloning? So like if you saw a repository back in github.com, for example, like in the cloud, and you want to, for example, like keep a local copy of it, such as then you can get the latest changes from the cloud, or you want to push changes from your laptop to the cloud, the first thing you need to do is cloning. If you're going to be working with people, yeah, what you normally do is you set up a repository in a service like github.com, you and your colleagues, you clone it, and you start like contributing commits. So let's start like checking this process of cloning. What you're seeing here, and I'm going to copy paste this. This is a project I worked with Turing. It's a library for synthetic data generation. Like if you have a proper database with some data that's sensitive, you can use SQL Gen or SSD to create a duplicate of the database with some like random anonymous data. If you go, let me open Google Chrome. If you type that URL here, you go, you can see this is SQL and GN. It's been going on for a while. Just a bit of code there. So let's try and create a copy, a local copy on your laptop. I'm going to already edit code. You can copy the HTTPS URL of the repo. I think likely you can just copy the proper GitHub URL, but I'll play safe today and I will copy the URL from here. When you have the URL of the repo, again, let's call our handy command palette, and I'm going to type git clone. I'm going to just like, so if you have connected your VS Code to your GitHub account, which I did, you can go and explore the repository that you have created there. But I don't want to do it today. I'm just going to paste the URL, clone from URL, and I'm going to click. Now I need a destination. So I'm going to put it in documents, or maybe not, because when I was preparing this talk, I also cloned it. I will put it, I will create, can I delete it here? Yeah. Okay, I will put it in documents and I will select it as repository destination. Okay, doing it, and now VS Code is asking me like, where do you want to open? Do you want to create a new window? Do you want to open it right here? And I'm going to, just for convenience, I'm going to open it right here. And if you can see like the code that was on the cloud, now it's here, I have a local copy. If there are some changes that the SQL engine developers are doing on the cloud, for me, it's easily with a full operation. Sadly, I don't have time to cover it today. If I want to contribute to the repository, I can do pull requests and they can be merged into the cloud. And not time for do it today, but something I really want to do today before I finish is giving you a couple of tips of code navigation that I use them a lot. So one first like hotkey that I like to use it a lot, it's called Command P, which lets me open files by name. So I know there's some make script here. So you can, if you know the name of the file that you want to modify, and there are a lot of files like here, like you just run Command P, you type the name, and then it's ready for you to modify. Now, like this module is quite big. Like I think we have like more than 500 lines of code here. Now, like if you know the symbol that you want to modify or to work on, and by simple I mean like function definition, class definition, global variable, you can type Command-Shift-O, and then you can go directly to the symbol that you want to modify. I want to explore the make table generators file. You see, I just found it, click it, and I'm there right now. And some other very, very useful navigation tip that I use it a lot is like looking line 397. There's a table generator file. Let's say like I really, really want to modify it. If I press Command, it's underlined. So now I can just click, and VS Code takes me directly to the symbol definition, so I can modify it. Sadly, I don't think we have time for more questions, so I'm going to stop there. I will be sharing the slides with Helen, so if you want to check our code on branching and on Jupyter Notebook. But maybe we have some couple of minutes for questions, Helen?
Yeah, I mean, number one, thank you for the talk. I'm sorry that it's gone a bit over. I feel like that was maybe because we were interrupting you during, but hopefully that was helpful for people still. But yeah, thanks for the talk, Carlos. It was really good and hopefully helpful. Maybe people have some questions that they would like to ask. I saw in the chat earlier someone asked, why is it better to use VS Code rather than Jupyter Notebooks? If you
yeah, I don't think one is better than the other, but like if you use Jupyter Notebooks within VS Code, sadly I didn't have time to cover that. Like for example, that feature that Levan was mentioning, it like having the variable explorer. I want to check the variable that I have in memory at some point in time. You can do that with VS Code. We have some nice visualizations as well. Like if you have like, for example, a data frame variable, you can see it in a very nicely formatted table in VS Code. You can filter data. But if you're really interested in how to like use Jupyter Notebooks and VS Code, in the slides, there's a link with a really nice tutorial.
Great, thanks. Does anyone else have anything that they'd like to ask while we're here? Well, as we said, we'll share the slides, so even the kind of content that we didn't have time for will be in those slides, so people can reference them. And as Carlos mentioned, like a lot of this content is, you know, VS Code does have documentation to explore these things, and this was kind of meant as a way, as an introduction for people who have heard a lot about it but aren't convinced. I hope Carlos has convinced you a bit. I think VS Code can really help you debug your code, especially even if you are someone that is like for the majority using Jupyter Notebooks or something like that. But yeah, did anyone else have any questions? Okay, otherwise, gonna wrap that up. Again, you can join our Slack, and hopefully Carlos can answer any questions after that there as well. We're going to be hosting another Tech Talk in 2 months' time. And I will send up a follow-up email with the recordings of this event and also the slides as well. But otherwise, I'm going to end the meeting here. Thanks everyone for joining.
Thank you for organizing this, and thank you to the audience.